Have you ever wondered how a tablet you swallow is able to cross from the stomach or from the GIT and enter into the systemic circulation? Yeah, basically that is what we are here to explain today. How the tablet that you're swallowing is able to get into the blood, and then the factors that could actually affect that. Yes, so what is absorption? As we said earlier on, absorption is the movement of drug from the site of administration into the blood circulation or the systemic circulation. And when you swallow a tablet, the tablet, just like the food that you're eating, it's going to go through the esophagus into the stomach and then into the intestine. Now, once a drug enters into the GIT, for instance, if you swallow a tablet, it is going to undergo disintegration. That means the tablet molecule is going to break down and release the granules, and then these granules can deassociate and liberate the different particles that are within them, and then these particles undergo dissolution. Once they are dissolved into the intestinal fluid, then there they are ready to be absorbed. Now, for this drug to move from the lumen of the GIT into the blood circulation, there are mechanisms that are involved. We are going to cover specifically about 4 mechanisms. The first one is simple diffusion. Simple diffusion is the movement of substances or molecules from area of high concentration to their areas of low concentration along a concentration gradient. So just like when you spray a perfume from one corner of the room, it's going to spread from that area of high concentration to other areas of low concentration. That is exactly how those drugs move. They move through simple diffusion, just from the site of administration where the concentration is very high to into the systemic circulation where the concentration is very low. And most of the drugs are actually absorbed by simple diffusion. The second mechanism is facilitated diffusion. It still follows the same principle that the drug is moving along a concentration gradient, but here the movement is aided by the aim of the channel proteins and the carrier proteins that help to carry specific molecules and move them along their concentration gradient. And then the third mechanism is active transport. Here the drug molecules move against concentration gradient. They move from their area of low concentration to an area of high concentration. That is to say, they move against a concentration gradient, and it involves the use of energy. The mechanism utilizes energy in the form of ATP to carry drugs from low to high concentration. And then the other method is endocytosis. That means the cell membrane is going to engulf a drug molecule. After engulfing, it phagocytoses it and then takes it into the cell, and then it can now exocytose this molecule into the systemic circulation. Medicines that does not just flow from the intestine into the systemic circulation. Why? Because the lumen of the GIT is made of the phospholipid bilayer that does not just allow any molecule to pass through. So that's why the different mechanisms come into play. Then the other mechanism that is not so common is the pinocytosis, where the drugs moves in between those tight junctions in between the cells, and then they are able to move from the lumen of the GIT into the into the blood circulation. As simple as that. And then there are several factors that affect absorption. There are physical-chemical properties of the drug, and then the anatomical and physiological factors. And then when you look at the physical-chemical properties of the drug, the molecular size or molecular weight of the drug affects absorption. you find that smaller molecules can easily dissolve and can easily diffuse across the membrane, unlike large molecules that can be obstructed from moving. So drugs with smaller molecules passes faster. Yes. And then the other one is the lipophilicity of the drug. Drugs that are highly lipid soluble easily pass through the phospholipid bilayer that makes up the membrane of the GIT. So they are easily transported across the membrane, unlike hydrophilic drug that may not really get absorbed as fast. They don't move very fast, so they move very slowly. Then the other thing is ionization of the drug or charged molecules. So the uncharged or unionized drugs are actually absorbed faster. They diffuse faster across the membrane as compared to charged molecules. That's why unionized drugs are absorbed faster than the charged or ionized drug molecules. Then the other thing is pH. pH actually just affects ionization. You find that weak acidic drug like aspirin, for example, or the ibuprofen, most of these COX inhibitors, they are weak acids, and then you'll find that these medicines, when they reach the stomach, they become uncharged. When you expose a weak acidic drug to an acidic environment, they lose their charge and they become unionized, and there the medicine is readily absorbed. Yes, just like also weakly basic drugs are absorbed in the small intestine. Yeah, basically those are the physical chemical properties. And then the anatomical and physiological properties are things to do with the surface area of the absorption site or the site of administration. That's why the villi in the small intestine, that's where most of the medicines are absorbed, because of the villi that increases the surface area and increases the amount of contact of the drug molecule to the absorbing surfaces. And then the other thing is blood circulation. Highly vascularized areas, medicines are absorbed faster. Why? Because the drug is able to carry away the drug. The absorbed drugs are carried away very fast to create that concentration gradient such that diffusion can move faster. That's why medicines that are given buccally, some medicines are put under the tongue because of very high blood vessels that supply and carry away the blood from that area. So at every time, a very high amount of the drug, a very large proportion of the drug is carried away, and that increases absorption. Then lastly is the gastric emptying. So when someone has diarrhea, the contact time of the drug in the GIT is very small, and that reduces absorption. Then the other concept is the fast pass effect. Fast pass effect is just the metabolism of this drug before it actually gets into the systemic circulation. So when you swallow a tablet, it gets absorbed and goes into the portal circulation, where it exposes this drug to the liver enzymes. And then the enzyme can destroy or can convert some of these drugs before it can even get into this general circulation. So you find that some of these drugs can actually be made inactive before it even gets into the circulation. So that's why orally administered drugs can have a very low bioavailability, because of that fast pass metabolism that destroys or denatures some amounts of the orally administered drugs. Yeah, so basically that is it. When you swallow a tablet or a capsule, it goes into the site of administration or into the intestine or the stomach. It's going to disintegrate, it's going to deassociate, it's going to release the drug from the granules, and it undergoes dissolution and finally enters into the what? Into the systemic circulation. Yes, basically that's what I wanted to discuss with you this morning. Thank you for watching. Be sure to subscribe to the Drugs Knowledge